Right, so in the golden ages, Superman could jump over a tall building in a single bound. So the 100 tallest buildings in the world are all over 250 meters. So as a tall building, we'll use 250 meters as a reference point. And assuming that the average human on Earth can jump 1 meter to keep the math simple, a little generous, but hey, we can find out if this is true. So we'll use the formula d equals distance equals speed times time, and we'll use speed equaling acceleration times time. And so the distance he jumps on Krypton is 1 meter, and that we're using the average speed, which is 1/2 the original velocity when he leaves the ground. We're multiplying that times time, so this is average speed. Time is going to be VO, original velocity, over G, just extrapolating that from here, where T equals S over A. Alright, so then on Earth he jumps 250 meters with 1/2 VO, with VO over the G on Earth is 9.8. Right, and so you solve for the VO, you find out that it is 70. So plugging 70 back into this VO, you find out the G on Krypton is 2450, which is roughly 50 times that, roughly 250 times that on Earth's G. So using that, we know that the gravitational force on Krypton has to be 250 times greater than the gravitational force on Earth. So we use our handy-dandy equation here. For gravitational force. And then we solve for acceleration. We get the gravitational constant times the mass of the planet over the radius squared. Right. And so now we're going to use density. So we find, this is also equal to using density, which is mass over volume, with the volume of a sphere being 4/3 pi r cubed. We can say this is equal to 4/3 pi times G times the radius times the density. So for density, we're going to go ahead and assume that Krypton is made entirely of iridium, which is the densest naturally occurring element. And it has a density of 22,560 kilograms per meters cubed. So if we plug that in to this formula here, we get times 4/3 pi times the radius times the density, and we find, and this G is going to be equal to 9.8 G of Earth times 250, which is what we get over here. 9.8 times 250, and here we're solving for the radius. So if you just do some algebra here, you find that the radius is equal to 3.887 times 10 to the 8th meters, right? And that is about half the radius of the sun, which is pretty ridiculous, especially for a solid planet, let alone a planet that is made of the densest element, the densest naturally occurring element that we know of. Right, so we can extract just a little bit more data from this. Using this formula again, we can solve for mass this time, where mass is the gravitational acceleration times r squared, gravitational constant, just plugging numbers in, g being that, r squared being that, gravitational constant being gravitational constant. We find that the mass is 5.55 times 10 to the 30th kilograms. Right? And that is
over 2 times the mass of Jupiter. And Jupiter is a gas giant made almost entirely of gas. The only reason it is capable of existing is because it's made entirely of gas. It is impossible for a planet to be a solid planet to be that large, let alone, once again, made entirely of iridium, the densest naturally occurring element. So the whole concept of Superman being able to jump higher because he was on a planet with a higher gravitational force is just completely ridiculous, because that planet just simply could not exist with everything we've discovered up to this day in science.